Let's see how to solve the problems in self exercise 5.7. Okay, question number 1. It is found that 35% of Form 5 best study pupils achieve a grade B in additional mathematics. If 6 pupils are randomly selected from that class, find the probability that 6 pupils achieve a grade B. So in this case, the value of P is 35%, which can be written as 0.35. And from here, we also can get the value of Q. Q is equals to 1 minus 0.35, so which is 0.65. And the value of N is going to be equals to 6. So for section A, what we need to find is Px equals to 4. So basically, it's going to be 6C4 times with 0.35 to power of 4 times with 0.65 to power of 6 minus 4, which is 2. Okay. So I'm going to key this as 6cx. The reason why I key x here is so that I can use it for the next question as well. So multiply with 0.35 to the power of x, multiply with 0.65 to the power of 6 minus x. Okay, then we press calc. The value of x is equals to 4. The final answer is 0.0951. 0.0951. Okay, let's look at question B. Find the probability that more than one pupil achieve a grade B. Okay, more than one, meaning Px greater than 1. Px greater than 1 means it's going to be Px equals to 2 plus Px equals to 3 until Px equals to 6. But if you do that, it's going to take a lot of time to do this calculation. So rather than we find Px equals to 2 until Px equals to 6 and then we add them, alternatively we can just write 1 minus Px less than equals to 1. Okay, so by doing so, we just need to find Px equals to 0 and Px equals to 1, and then we minus from 1. So this is a much more easier way of answering this question. Okay, let's find the value for Px0 and Px1. So when x is equals to 0, we get 0.075. 1 minus 0.0754 minus x equals to 1. So we get 0.2437. 0.2437. Okay. The final answer is 1 minus 0.0754 minus 0.2437. And I get 0.6809. 0.6809. Done. Okay, let's look at question number 2. In a study, the probability that a certain type of smartphone is spoiled after 3 years is 78%. So meaning, if we select number of phones, the probability of getting one spoiled phone is 78%. Okay, so by taking what we call getting a spoiled smartphone from number of trials as a probability of success, so the value of P is equals to 0.78. And if you look at question A, if 7 of these smartphones are randomly chosen, so the value of n is going to be 7. So for section A, find the probability that 4 of them are spoiled after 3 years. So Px equals to 4. And it's equals to 7C4 times with 0.78 to the power of 4 multiplied with 0.22 to the power of 7 minus 4, which is 3. Okay, so don't forget q is equals to 1 minus 0.78, which is 0.22. Okay, and the answer for this question is actually can be calculated from the calculator. So 7c x multiplied with 0.78 to the power of x multiplied with 0.22 to the power of 7 minus x. Okay, we calc and then key in 4, and we can get the answer 0.1379. 0.1379. Okay, section B, find the number of smartphones that are spoiled if the sample is 200. Okay, 78% is the probability of the smartphone spoiled for the population. I mean for the bigger sample. Okay, but for a sample of 200, the probability of an handphone spoil we calculate based on section A. Okay, because out of the 7 handphones, 4 handphones are spoiled. Okay, and then we also consider the probability of one handphone spoiled after 3 years. So by combining these two, the probability of handphone spoiled in this sample is actually 0.1379. So we know that P A is equals to NA divided by NS. So the meaning of this formula is the probability of an even A is equals to number of even A divided by the sample size. So in this case, the even is actually a smartphone is spoiled. Okay, and the probability is 0.1379, and we're going to find the number of smartphones spoiled. Okay, I just write n and divide by the sample size, which is 200. So the value of n is 0.1379 times with 200. So we get 27.58. So we round off this value and we get 28. Okay, let's look at question number 3. In one report, 54% Malaysians buy locally made cars. If 8 people who just bought new cars are selected at random, find the probability that A, at least 2 of them bought locally made cars, and B, more than 6 of them bought locally made cars. So in this case, the value of P is equals to 0.54. So therefore, the value of Q is 0.46. And the value of N is equals to 8. And for section A, Px equals to, not equals to, actually at least 2 means is greater than equals to 2. Okay. Okay, if you take Px equals greater than equals to 2, then we have to take the probability for Px equals to 2 until Px equals to 8. So this involves a lot of calculation, right? Rather than we sum up all these values, we can just take 1 and then we minus px less than 2. So here we just need to calculate the probability of x equals to 0 and probability of x equals to 1. Don't forget to put the bracket. Okay, so 1 minus 8c0, 0.54 to power of 0, 0.46 to power of 8, and minus 8c1, 0.54 to power of 1, multiply with 0.46 to power of 8 minus 1, 7. Okay. And let me find the value for px0 and px1. So 8 should divide okay, x times with 0.54 power of x multiply with 0.46 to the power of 8 minus x. Let's calculate the value for px0, and what I get here is 2.005. 1 minus 2.005 times 10 to the power of negative 3 minus, okay, the value of x is 1. Okay, we get 0.0188. 0.10188. Okay, so 1 minus 2.005 and about negative 3 minus 0.0188, and what I get here is 0.9792. 0.9792. Okay, so this is the answer for section A. Okay, more than 6 of them bought locally made cars. So meaning we have to take px more than 6. More than 6 means greater than 6. So here we just need to take px equals to 7 and then plus with px equals to 8. Okay. So don't write 1 minus px less than equals to 6. So if you do that, you have to calculate a lot of values. Okay. So 8c7, 0.54 to the power of 7 times 0.46 to the power of 1 plus with 8c8, 0.54 to the power of 8, 0.46 to the power of 0. Okay, so the value of x is equals to 7. 0.0493. 0.0493 plus with 7.230. 7.230 times 10 to the power of negative 3. So let's sum up these two values. Okay, 0.0493 plus with 7.230 10 to the power of negative 3. The final answer is 0.0565. 0.0565. Okay, let's look at the next question. It is found that the probability of an electronic factory to produce faulty printing machines is 0.05. 5 printing machines are randomly chosen from the factory. A. Construct a probability distribution table for the number of faulty printing machines and then draw a graph. And B. From the table or the graph, find the probability that number 1, exactly 2 printing machines are faulty, and number 2, more than 1 printing machine are faulty. Okay guys, Let's look at section A. So first of all, we know that the value of P is 0.05. So therefore, the value of Q is 0.95. Okay. How about the value of N? N is equals to 5. Because 5 printing machines are randomly chosen. Okay. Construct a probability distribution table. So the value of X is actually from 0 until 5. Okay. So in the first column of this table, I'm going to write the values of R. So the value of R is 0, 1, 2, 3, 4, and 5. And in the second column, I'm going to calculate the probability of each of these values of R. So the first one, 5C0, 0.05 to power of 0, multiply with 0.95 to power of 5. Next, 5C1, 0.05 to power 1 times 0.95 to power of 4. 5C2, 0.05 to power 2 times with 0.95 to power of 3. 5C3, 0.05 to power 3 multiply with 0.95 to power 2. 5C4, 0.05 to power 4 times with 0.95 to power 1. The last one, 5C5, 0.05 to power of 5 multiply with 0.95 to power of 0. And let's calculate the value of each of this using the calculator. Okay, so as usual, I'm going to use Excel in this calculation. 5 shift divide and then X multiply with 0.05 power of X multiply with 0.95 to power of 5 minus X. And let's calculate. We start with 0. Okay, the answer is 0.7737 something. Okay, I'm going to change the number format. Okay, I select fix and number 4. So what happened? The calculator will convert the answers correct to 4 decimal places. The first value here is 0.7738. 0.7738. Okay, next, when X is equals to 1, we're going to get 0.2036. Next, when X is equals to 2, the value is 0.0214. 0.0214. When X is equals to 3, the value is 0.0011. And when the value is equals to 4, okay, so the value is very small. When we write to 4 decimal places, we only going to get 0.0001. Okay, and the next one also we're going to get the same thing. Okay, so based on these values, we're going to draw a graph. Okay, so let me label here is okay 0, 1, 2, 3, 4, and 5. Okay, the highest value is 0.77. So when we round out this to decimal places, we get 0.8. So what I can do here, I label here 0.2, 0.4, 0.6, 0.8. Okay, so when x is equals to 0, we get around 0.77. 0.77 should be okay somewhere here. Okay, next 0.20, the value is here. 0.002. Okay, it's going to be one small box, and the rest very small until you cannot mark on the graph. Okay, and this is what we get. Okay guys, let's move to section B. From the table or the graph, find the probability that exactly 2 printing machines are faulty. Okay, for part B1, just look for the value of x equals to 2, and the answer is 0.0214. So for B1, Px equals to 2, the answer is 0.0214. And then for section B2, more than one printing machines are faulty. Px greater than 1. Okay, greater than 1 means okay, we have to take the value of r equals to 2, 3, 4, and 5. But rather than doing that, we can easily take the values of probability when x is equals to 0 and 1, and we minus these two values from 1. Okay, so 1 minus px less than equals to 1. So it's going to be 1 minus 0.7738 minus 0.2036. So let's calculate the value. 1 minus 0.7738 minus 0.2036, and I get 0.0226. 0.0226. Okay, that's it. Okay, and we also can find this answer from the graph, but the problem is maybe the answer that we get from the graph might not be accurate as the answer that we get from the table. Okay guys, let's move to the next question. Question number 5. Okay, the diagram on the right shows a binomial distribution graph for discrete random variable x. Section A, state all the possible outcomes of x. And B, find the value of m from the graph. And C, find the percentage of probability x greater than 2. Okay, so let's start with section A. And if you look at the table, if you look at the graph, the horizontal axis start from 0 and then it end at 5, end with 5. So therefore the possible outcomes of x 0, 1, 2, 3, 4 and 5. Okay, next, section B, find the value of m from the graph. Okay, so we know that the value on the vertical axis actually represent the probability, and if you sum up the height of all these lines, we get the total probability, which is equals to 1. Okay, so I start with 1 over 4m plus with 1 over 9 plus m plus 2m plus 5 over 36 plus 1 over 36, and the sum should be equals to 1. Okay, so we sum up 1 over 4 plus with 1 plus 2, so I get 13 over 4m. 13 over 4m equals to, okay, so I take 1 and then minus 1 over 9 minus 5 over 36 and also 1 over 36. Okay, the answer is 13 over 18. 13 over 18. Okay, so therefore the value of m should be 4 over 18. Okay, we can simply cancel out the 13, and the final value of m is actually 2 over 9. Okay, next, for section C, find the percentage of probability x greater than 2. Px greater than 2. Px greater than 2 is equals to 1 minus Px less than equals to 2. So I take 1 and I minus with Px equals to 0 minus Px equals to 1 minus Px equals to 2. Okay, so in fact you also can sum up Px equals to 3 plus with Px equals to 4 and Px equals to 5. Okay, so you'll get the same answer. So 1 minus Px equals to 0. Okay, it's 1 over 4 times with 2 over 9. Okay, don't forget to substitute the value of m. Minus Px equals to 1, which is 1 over 9, minus Px equals to 2, which is m. So it's 2 over 9. Okay, 1 minus, okay, I simplify this, so I get 1 over 18 minus 1 over 9 minus 2 over 9, and the answer is, okay, 11 over 18. Okay, but the question asked you to give the answer in percentage. So let's multiply this with 100 and I get 61.11%. 61.11%. Okay, let's look at question number 6. In a study, it is found that 17% of the Malaysians aged 18 years and above have diabetes. If 10 people are randomly selected from that age group, find A, the probability that 5 of them have diabetes. So here we have to find Px equals to 5. And based on the information that given, the probability of success, which we get a person with diabetes, 17%, which is 0.17. So therefore the value of Q is going to be 1 minus 0.17, which is 0.83. And since we select 10 people, the value of n is going to be 10. So Px equals to 5 is going to be 10 C5 multiply with 0.17 to power 5 multiply with 0.83 to power 5. Okay, so 10 shift y x multiply with 17 to power of x multiply with 0.83 to power of 10 minus x, and I press calc. The value of x is equals to 5 and we get 0.0141. 0.01. And next for section B, the probability of x in between 2 and 6. So Px, x between 2 and 6. So when x is between 2 and 6, basically it's x equals to 3 plus x equals to 4 and x equals to 5. Okay, so let's calculate these three values and then we sum up. Okay, and in fact we already have Px equals to 5, so we just reuse it. So 10 C3 0.17 to power 3 multiplied with 0.83 to power 7 plus with 10 C4 times with 0.17 to power 4 multiplied with 0.83 to power 6 and we plus with 0.0141. Then calc x equals to 3. Okay, 0.1600 plus with x equals to 4 plus 0.0573 and we plus with 0.0141. Let's plus these three values 0.1600 plus 0.0573 plus with 0.0141 and the final answer is 0.2314. Okay.